Hello everyone, I hope everyone is doing extremely well. So today we are going to be doing rotate image LeetCode 48th question. So let's see what the question says. It says that you are given an nxn 2D matrix representing an image. You have to rotate the image by 90 degrees. So let's directly look at the example. So the example is that in the first table you have 1, 2, 3, 4, 5, 6 and 7, 8, 9. Once you right rotate it by 90 degrees, it gives you 741, 852 and 963, as you can see here, right? So this is the original table and then this is the rotated table. So to give you a better example around this, so I have copy pasted this table over here. So let's see what it actually means. Let me copy it. I'll paste another variant of it. So what do they exactly mean when they say right rotated by 90 degrees? So if I right rotated by 90 degrees like this, isn't this what we were looking for when we were trying to right rotate it? So see, in this table we have 7, 4 and 1 as the first row, which is exactly what is shown here, right? So this is what it means when you say right rotated. So you have basically right rotated it in this direction by 90 degrees. So given this, you have to convert this into this right rotated matrix. So let's see how we can tackle this question. So see, in every matrix question, we basically have to try to deal with indexes. So let's try to look at it from that perspective. So I'll discuss the first approach, the first and most intuitive approach. So let's look at the indexes. So let's say if I talk about, let's say this row first, or maybe let's talk about the first row itself. Let's say I'm talking about 1. If I talk about 1 in the original matrix, the indexes are 0, 0. But in the updated array, the rotated array, you can see that this has been converted to 0, 2, right? There's no rocket science in this. If I talk about 2, it is 0, 1 in the original array. But here, if you see, it has been shifted to 1, 2. If I talk about 3, here, if you talk about 3 has been converted to this, it has been shifted to this index. So basically what it means that initially 3 was at 0, 2, but now it is shifted to 2, 2. So this is how the indexes are shifting. So when you try to look at it from the index perspective, you will have a very interesting observation that the first row has here become the last column, right? The second row has become the second column. Even our index situation is showing us the same thing. The first row has become the last column. If I take another example around this, if I say take an example of 7, 8, 9. So for 7, 8, 9, this 7. So 7 in the original array was at 2, 0. But in the new array, it is at 0, 0. If I talk about 4, it was initially at 1, 0. But now it has been converted to 0, 1. If I talk about 1 here in the original array, one was at 0, 0, but now it has been shifted to 0, 2 here, right? This has been shifted to this. That is why 0, 0 here is now shifted to 0, 2 here. This is exactly what the index situation tells us. So here again, looking at the exact same example. So see, as I mentioned that the rows become the column. So, and the column becomes the rows. So here, see, the exact same thing is happening. The 0th column has become the 0th row. See, both of these are constant. And about this row situation, you can see this is alternating. The last row is now represented in the first column. The first row here is represented in the last column. So please keep all of these things in mind. So see, do we have a correlation here? Yes, we have. Yes, we have. Let me show you how. Basically, we just need to formulate the index situation, and if we are able to formulate the index situation in a good way, then the question is going to be very easy for us. So let's see what is happening. So let's say in the original table, I'll call this original table. Original table is called as T, and let's say this is the new table. This is called as, let's say, N. So can we say, looking at this example, if you see, we just have to calculate where this position is going to be in the new row. Like right now, because we have the answer right in front of us, we know that 0, 0 will be at 0, 2. If we can somehow calculate this original table value where it will lie in the new table, wouldn't our question be very simple? Because then we'll just iterate over all the elements of this matrix and we'll place them at the right spot. So let's say 0, 1 will be placed at this spot, 2 will be placed at this spot, and so on. So we'll do this for every element of the matrix. Now, basically the question has boiled down to, if my original array indexes are I, j, and let's say my new array indexes are x, y, we just have to see how we can correlate x and y and I and j. So let's see how we can do it. Okay, let's look at one more interesting observation. This column, that means j, is equal to this row, that is x. So this gives us a very direct correlation. So if you want to calculate x, x will be equal to j. Isn't that what it is? See, again, this is j, this is x, and both of them are exactly the same. So if you want to calculate x, which is the new array index, will it not be equal to this j? That is exactly what I've written over here, right? So we have a formula for x. Now if we want to have a formula for y, so let's see how we can calculate y. Here you can see y is completely constant, but how are we deriving this value? As you can see, I mentioned that the first row has become the last column. Owing to this observation, can we say that if the entire number of rows was n, let's say here, which is 2, is this not exactly just subtracting this value from this value? So let's say if I have n minus I here, isn't this what it is? So the first row has become the last column. And then taking another example, the last row has become the first column, and then here the first row has become the last column here. That is why we arrived at this solution. Y is basically n minus I. Isn't this making complete sense? Yes, it is. Okay, so we are on the question now. So let's try to implement what we just saw. So here I have the code ready. So let's say we have defined that the number of rows is R, the number of columns is C, and we are taking a new array here. We have taken this R length so that we identify the last row. Since R, the indexes start with 0, right? The last index would be matrix length minus 1. So here what we're doing is we are trying to traverse each and every individual element in the matrix. So let's say we try to traverse from 1, then 2, then 3, and at every iteration we are trying to place the element in the new array at the right spot. So we just saw how we calculated x and y. X and y was the new array, new matrix indexes for I and j. So as we just saw that x was j and y was rlen minus I. So I, in the board, I just mentioned n minus I. So here I'm saying rlen minus I. So here in the new array, we are taking x and y and we are placing it at the right spot. So the matrix ij will be put in position xy. Now this will curate our new array, which will be right rotated, which will have the elements as 7, 4, 1, 8, 5, 2 and 9, 6, 3. But then the question asks you to rotate it and put it in the original matrix as well. So just for that, we are again traversing through the entire new matrix, and then we are placing every element inside the original matrix. So this is just for that. So n is having all the updated items, and using the new matrix, we are putting it in the original array, original matrix. So that's it. I think if I submit it, if I run it, it'll be accepted. If I submit it, so it'll be accepted. Okay, so that was the brute force method of it. Now the interviewer would not be happy because you have used an extra table, because while traversing the original table T, you made a new table and then you place the values in that new table. So the interviewer might ask you to do it in place. When we say in place, it means that you don't have to use any extra space. You have to only work with the existing table, and you have to make sure that the values get reflected without using any extra space. Okay, so let's see how we can do that. So now again we will have to look at this observation, that this column has now become this row, and then this middle column has now become this row, and now this has become this. Now I'll show you one very interesting correlation around this. Let's say if I take a transpose of this. The transpose is basically you convert the rows to columns and columns to rows. This is exactly what is happening, right? This column became this row. This column became this row. That is exactly what is happening. So that hints us that we can take a transpose of it. So let's try to take a transpose of it. So if I try to take a transpose of this table, let me again copy it. I think I have it copied. Let me get it from here. Okay. Here, if I try to take a transpose of this table, let's see what's the output that we get. So in transpose, you convert the columns to rows and the rows to columns. So if I try to quickly explain, because this is not a transpose tutorial, so just quickly explaining it, the middle elements remain at the same spot and the elements switch from the diagonal. This is what transpose is. To calculate transpose of a matrix, you basically convert rows to columns, which means that T of I, j becomes T of j, I. I will make sure that I traverse the matrix below the diagonal. So what that means is that first I'll go to 1, which is 0, 0, and I will make sure that I don't cross the diagonal. So here 1 is on the diagonal, so I'll not move ahead of it. Going to the second row, I will be at this spot, 4. So for 4, I will say that 1, 0, you convert this to 0, 1. You swap it basically. So if I swap 1, 0, which is this, with 0, 1, I will have 1, 4 and 3. So if I try to make a new matrix, let's try to fill the new matrix. This is not a new matrix. This is basically just the same matrix. We're just swapping the values. So this was the diagonal. The diagonal stays the same. And let's say we were at this spot, 1, 0. Now what happens over here is that we use this formula. Ti, j is equal to j, I. So basically 0, 1 is 1, 0. That means that 4 will be swapped with 2. So basically here we will have 2, here we will have 4. After that we'll hit the diagonal again, right? So we will not move ahead of the diagonal. Now let's say we are at the new row. So we are at the 2, 0 index, which is 7. if I use the same formula ti comma j, which is 0 comma 2, you convert it, you swap it with t2 comma 0, which is, let's see where 2 comma 0 is. So we will swap this and this across the diagonal basically. So here we will have 3 and here we will have 7. Now going to the next element, we are at 8. So again 8 will be swapped with 6. So this is the transposed matrix. So here we have the transpose matrix. I'll write transpose. So let's see, is this the answer? No, this is not the answer. But once you take a transpose of it, you'll see that this is very close to the actual answer. How? So see, this is 741, but here it is 147. So basically every row is just in the reverse order of what we want it to be. So it should have been 741, but it is 147. So now we have the transpose. Let's say if I talk about only the first row, if I just reverse this, will I achieve my answer for the first row? Yes, I will. Why? Because here we saw that the first row became the first column, and this is exactly what we have done here. By taking a transpose, you exactly do that. It's just that it's in the reverse order as compared to when you rotate it with the 90 degree. So here we can easily take a transpose and then we'll go individual row by row and reverse the order. So now this 147 will become 741. I hope everyone is aware of how to take reverse of a array, so I will not be explaining that, but you just simply have to traverse through every row and just reverse it. Here 258 will become 852, 369 will become 963. Now let's see, is this the answer? Yes, it is. So see, 741 852 963, 741 852 963. So basically, summing all of this up, you first have to take the transpose of the original matrix and then reverse every row. That is all that is there. Take a transpose and then reverse rows. So if we make a function where we first calculate the transpose and then we pass that transposed matrix and we iterate through every row and try to reverse all the elements, then we will arrive at the answer. So this is exactly what needs to be done. So I hope that is clear. So let's move on to the code now. So let's try to implement the new approach, which is the most optimal approach. So according to the most optimal approach, we'll just first take transpose of the matrix. Let's say we have a function that just gives you the transpose of the given matrix, and then we reverse rows as we just discussed in the solution. So if we just do these two operations, we would arrive at our answer. So let's try to implement the transpose function now. So here I'm not doing anything, I am just trying to take transpose of the matrix as we just discussed during our discussion. So here we will try to go through every row. Let me take r is equal to matrix dot length and c is equal to matrix 0 dot length. So here is the catch while taking transpose. We will not run this loop till the entire columns. We will only run it till we have encountered the diagonal, and to encounter the diagonal we'll have to cross through the ith index. So that is why j is less than I. So for 0th row it'll run till 0. So here in the example you can see for the first row diagonal is at 0. For the second row diagonal is at 1. Or if I try to simplify it down further, for the 0th row the diagonal is at the 0th column. For the 1th row the diagonal is at the 1th element. on the 1th column. So that is why this j is less than equal to I. So while taking transpose, as we know that we will swap it. So here we'll write the logic for swapping. So this function gives us the transpose. All right. Now, okay, let's just run this for now and let's see what the output is. So see, here when we take the transpose, the answer is 147, which is the reverse of 741, 258, which is the reverse of 852, and 369, which is the reverse of 963. So all we need to do now is take the reverse of every row. So we'll write a function for that as well. So what do we need to do in this reverse rows? Here, all we need to do is just reverse the entire row. So for reversing the entire row, we will implement the logic. So what I'm trying to do here is I've taken one start element, I've taken one end element, which is representing the starting element. Let's say 1 is the starting element and 3 is the ending element, and we keep on swapping 1 with 3. Then we'll left shift the end and we'll right shift the start. Once we are done with the swapping, all we do is just increment the start pointer and decrement the end pointer. So this will happen for every row of the matrix. This is the first row, this is the second row, this is the third row, and then the first the transpose will be taken, and then every row, individual row, will be reversed using this logic. So let's just try and run it. So see, this was successful, and if I submit it, it will get submitted as well. So I hope this is clear to you now. We basically just need to take transpose and then we need to reverse the rows. So when we go using this approach, we have not taken any extra space. So see, here we are directly making all the changes within the same matrix. Thank you so much for watching the video. If you found value out of this video, please make sure you like and share this video to anyone who wants to learn DSA. I will be adding more videos to the playlist, so please make sure to subscribe the channel.